Hey, I thought you might be needing some help with net ionic equations, so I made you a little video for that. You can read this page. You don't need my reading it to you. Be aware that those things that are not participating in the making of the precipitate are called spectator ions. And the reaction we're going to be looking at is the one that produces solid lead-2 iodide. The graduate cylinder at the top of the page is pouring out a solution with lead-2 ions in it, clear, colorless, looks like water. And in the beaker there's a clear, colorless solution of some kind of iodide solution. And where those two meet, we make the bright yellow lead-2 iodide solid precipitate. Looks kind of cloudy at this point, very bright. It's a classic reaction that you will see again, I'm sure, if you take more chemistry. So the lead nitrate solution reacts with potassium iodide solution to produce solid lead-2 iodide potassium nitrate. First thing you have to do when you get a problem like this, you got to turn those formulas into names, or names into formulas, sorry. And the charges are very important in that. I've gone ahead and written the charges on. And that's how we come up with those formulas. If you still struggle with that, you might want to find some help on writing those formulas, because that does not go away. So we're just going to use what we had there on the other page. PbNO3 2 AQ. Your teacher may or may not want the AQs on there. Oops. Yeah. And if you look at your solubility chart, on a double replacement reaction such as this, one of the products needs to be insoluble. We write that with an S for solid or insoluble. And lead compounds tend to be precipitates. If you're not sure and you got lead, silver, or mercury, that's going to be your precipitate. If you've got any sodiums, potassiums, lithiums, nitrates, acetates, they're not going to be your precipitate. So there's a molecular equation. That's the one you're most familiar with. We got that done and balanced. If you take some solid lead nitrate and put it into water, it's going to dissociate into lead ions and nitrate ions. Similarly with the Ki, it's going to make potassium ions and iodide ions. Notice there was 2 here. Sorry, I should have mentioned that. Because there's 2 in the formula, you're going to have 2 over there. And AQ, the aqueous solution in the products, is potassium nitrate. It'll stay separated as well. So for a molecular equation, everything is together. Complete ionic, we're going to separate all the AQs into their individual ions, which is what we were doing on the previous page. So see, we've got our lead nitrate becoming lead and nitrate. Same way with potassium iodides and the potassium nitrates. And the lead-2 iodide being a solid, we keep it together. So that's all there is to the complete ionic. And if we want to go from the complete ionic to the net ionic, we're only going to include the ions that change from one side to the other. Notice the lead here goes from an aqueous ion into the precipitate. So that's a change. The nitrate stays nitrate. Potassium ion stays potassium ion. The iodines, though, become part of the precipitate as well. So only, let's change that, what makes the lead iodide is what we're concerned about. So we'll have Pb plus 2 plus 2 I minus, making the PbI2. And there we have completed our net ionic equation. So really that's all there is to it. I tend to look for, when I'm doing this, I look for the one that's the solid and break it apart to make my net ionic. So here's another one we can look at. We're going to write the complete ionic, the molecular complete ionic and net ionic equations for the reaction of solutions of barium chloride and copper 2 sulfate. Oops. That erased. So the lead, or the barium chloride and the copper 2 sulfate, this is a double replacement reaction. So these guys are going to switch places. It works out nicely since both were +2, that the formulas are going to be very similar to on the other side. And of course, you'll need to consult your solubility rules to find out that the barium sulfate is the precipitate. The complete ionic, I've already got the left side broken up into the ions. The right side, the barium sulfate, is going to stay together. And the copper 2 ion and the 2 chloride ions are going to be separated. And then for the net ionic, well, it's just going to be whatever it takes to make the barium sulfate. And so that's all there is to it. To me, this complete ionic is the more tedious step. I won't say it's hard, but it's more tedious. Because from the first, right here, that's when I'm breaking apart. So, here's another problem. You can try this one. I'll see if I can get the answers down in the comment section below. And good luck with this, and let me know if you need more help.